Alright, we're from Embry Aeronautical University, and today we're doing the assembly design on CATIA. We're gonna work out a few toolbars in here, constraints, and the move toolbars. We're gonna start off by fix together command. What it does, it fixes together two parts, and it can have external um, constraints, and it will constrain the set. And you can have as many as constraints as you want within the set. But you can have only maximum of two external constraints. Now what I'm doing here, I'm constraining the center line of my pin to the center line of my lever, and also what I want to do is that I want to make a coincidence between the face, this face, and this face. I want it to be in the same direction. I click OK, I click on update. There you go, there goes my set. Now what I want you to do, I want you to go ahead and try out the quick constraint command. It's easy. It's a combination between the surface contact constraint and coincident constraint. It just guesses if you have an edge, it'll do coincidence. If you have a face or a plane, it'll do surface contact. So created a surface contact between these faces here, between the base and the brace, and using again the quick constraint command, I like to do an edge and this edge to be coincident. And that O here shows me that it's a coincidence constraint. This edge and that edge would also be necessary to assemble this part. And also using the coincident command, it does all the same thing. Using the trailing edge and the trailing edge of my braces, so they'll be aligned. And using the quick constraint, again, choosing the center line of my hole and choosing the center line of my brace hole here, and when I click on update, everything should be in their place, and as we can see, they're all in line and everything. So now the next thing we're going to explore, we already have our base subassembly all assembled up. Now what we're trying to demonstrate is flexible / rigid subassembly. To use that, you need to have a subassembly within your assembly, and this is our base. By default, CATIA has it as rigid. So in the rigid configuration, if I want to manipulate, let's say, the base subassembly, both of them move together as one. But if I want to make them flexible, now notice this little purple gear here. I just made it flexible. Choose this edge, and now they move independently, freely. I can manipulate freely. Now click on update, so everything is back together. Now, as you can see, these pillars are far away, so I can choose a smart move command, and it moves my part as it's constraining it at the same time. I don't need to click on update for that. So there we go. This is my pillar. The constraint is created. Click on OK. Now on the other hand, we have the snap command, and snap command does the same thing, but it just doesn't create the constraint. And as you can see, it's centered with my hole, but it doesn't have the constraint set up for it. Now what I like to do, I like to create a constraint using coincident command between the top of my pillar and the bottom of my surface, and I like them to face opposite. Click on OK. Click on update just to see everything is alright. Double click on it, everything wasn't alright, so we choose same, and there we go. it's in the right position now. Do the same thing. This time we're going to choose the coincident command just to demonstrate. Coincident in the center line of the pillar with the center line of my hole here, and that constraint is created. Now constrain the top face of my pillar with the bottom face of my brace, and the constraint is also created. Notice it doesn't move, unlike the smart move command. Click on update and it's in its place. Now we're left with the top lever, and what I like to do, I like to use the quick constraint command. Create a surface contact between this surface of the lever and that surface of the brace. Does a surface contact for me, and also a surface contact between this face of the lever and that face of my brace. Also insert a coincident between the center lines of the hole and the pin. And if I click on update, everything is in the same place. Now all we need to do is to create an angle. Before that, let's demonstrate how step manipulate on Clash works. For that, we need to delete all these constraints. Click on it. Put your compass on top of your pillar. Hold down shift, and when you move it down, it clashes with the base subassembly. It doesn't let it go through. Also over here it clashes with the lever. So it'll show you where it's clashing and where it's not clashing. So let's get it back to where it was, and let's create an angle constraint between this edge and that edge just to make it look good. And I'd like it to be about 30 degrees. I think it should look good enough, and it sure does. And this is our punch hole. And also what you can do, using the explode command, making these two products, both of them, as your selections, the base subassembly and the hole punch. The fixed product would be my bottom lid, and click on apply. And as you can see, you can actually variate how much they'll move accordingly. And if you click on OK, it'll ask you if you want to have the positions, and you click on yes, and you'll have an exploded view. It's particularly useful for drafting purposes, so you can click on every individual part face. And this is our video for today. Hope you had a great time.